Section 11-5, Part 3, overlapping triangles may have a common side or angle. You can simplify your work with overlapping triangles by separating and redrawing the triangles. Notice in this first figure we have triangle ABE. That's this triangle ABE if they were separated. And then we have triangle ADC. That's this triangle ADC. So if you were to take these two triangles and pull them apart, pull AEB to the left and ADC to the right, you would have these two triangles. By separating them, you can easily compare if triangles in one triangle are congruent to triangles of another and also their corresponding sides. Here we see that they both share angle A. So you see the markings. We know that angle A in this triangle is congruent to angle A in this triangle. So when you are comparing triangles that are overlapped, separate them. Pull them apart so that you can label their parts. All right, let's continue here. We have an example that we're going to be working with, overlapping triangles. So let's look at this example here. Finding similar triangles in diagrams with overlapping triangles. Decide whether each statement is true or false. Justify your reasoning. So let's look at A. Triangle LMP must be similar to triangle QMN. So we're looking at the triangle LMP and QMN. Now, I've kind of drawn these. I have pulled them apart. I have separated them and pulled them apart. So we're going to be looking at their corresponding angles, and see if we can find any relationship to prove that they're similar. If we can find two angles of this triangle congruent to two angles of this triangle, then we know this is a true statement that the triangles are similar. So let's go back to the original problem. Now, I see here that this angle is 43. These two angles form a straight line. From here all the way around, they form a straight line. So if you were to subtract 180 minus 43, you would get 137. So therefore, this angle is 137. These two angles are supplementary. They form a straight line. Now also this angle. Let's think about this angle. Together, this angle and this angle add up to 180. Well, this one was 43 as well. So just as the same as this side, 180 minus 43 tells you that this angle is 137. So we know that angle L is congruent to angle Q of our triangle. So I'm going to label angle L as 137 and angle Q as 137. Now, we must find another pair of angles to be congruent in order for us to prove that these two triangles are similar. So going back to my figure, we have LMP and QMN. Those are our two triangles. Well, I kind of pulled out the major important part. We know that this one's 137 because those two are supplementary. This one's 137 because those two are supplementary. But I want y'all to focus in on angle M. Both of these lines intersect at point M, this line coming down and this line coming down. And they have formed two angles that are opposite each other. These angles are called vertical angles. So angle M in this triangle is congruent to angle M in the triangle on the right. So if I went back to my two triangles, angle M is congruent to angle M. I'm going to put two markings. So since we know that two angles of this triangle are congruent to two angles of this triangle, then these two triangles must be similar. So for a part, this is a true statement. Triangle LMP is similar to triangle QMN.